Hello everyone, it's June the 7th. Alright, this is today's challenge. I'm not sure if I really want to go with this one. I mean, we had a rolling hash yesterday, was actually doing pretty well. There's one more solution to this, which is a try. I don't know, I just don't feel like going through the try. Maybe I gotta pick up some different problem to do today if this one goes by pretty fast. Okay, given a string considering only letter A and B, in a single step you can remove one palindromic subsequence from S. Return the minimum number of steps to make the given string empty. So one step, because that's already palindrome. We have done two steps. Considering only letter A and B. Okay, so we have A and B, and want to find out the minimum number of steps. So the minimum each time we can only remove a subsequence. Right, what happened after remove, let's say, BAA, that's BAA, wait, hold on, a subsequence. Oh, it's not a substring, the subsequence. Okay, so we can remove a subsequence, basically. And then we have A and B, right? That's two. Remove all the A's and remove all the B's. It is possible one. I see. Which means if the string itself is a palindrome, then that's one. If the string itself is not a palindrome, that's always going to be two. Yeah, so basically we say if and return 1 if s is equal to s this else 2. If is yep. Did I do the same logic last time? Alright, we have to do this. We have to record it. Things like this, you don't need test cases, and then we don't need it. Yeah, I know. Actually, I have some work to do today, so probably will do this after we finish this. This is the last time. Even simpler. I just pick another problem. Oh, I'm not sure. Alright, it's at 50%. Maybe it's not that hard. Could be deceiving. Like I said, I think I mentioned this before, right? If you have a high percentage of passing for a tough problem, it could just mean that it's a very, very tough, so people have to resort to the solution. But we're going to try. The appeal of a string is the number of distinct characters found in a string. For example, the appeal is 3 because it has 3 distinct characters. Given a string s, return the total appeal of all of its substrings. The total appeal of all of its substrings. Oof, how many substrings? That's O(n) squared to get all the substrings. Okay, let me get some water and think about this. Substrings. Okay, the question. If I know a substring, uh, what I'm trying to say. You have a thing A, B, B, C, A, right? All I want to know is, given a range, how many unique is in this range? How big is the string? Oof, 10 to the 5th. So let's say I have a range, right? How do I know? Good problem. So it's 10 to the 5th, it's not going to be O(n) squared. So there gotta be some, it's O(n) or O(n) log n at most. I mean, I will know. If given a string with all unique letters, right, then we can calculate it, right? If, let's say, given ABC, right, and then length 1 is ABC, length 2 is AB and BC. That's it, because it's substring. Length 3 is ABC. That's 1, 2, 3. Yes. And these will be 1 plus 1 plus 1. These will be 2 plus 2. These will be 3 by itself. So we can calculate this. Basically just 1 times n plus 2 times n minus 1 plus 3 times n minus 2 plus all the way, right? We can compute this. Okay. So in this case, wait, do we have a formula for this? This is n plus 2n minus 1 plus 2, 3n minus 3 times 2 plus what's the last? Last is 1, right? That's just plus n, should be n minus 1 times 2, because we have n minus 1 and 2. That's actually quite interesting. And the last one is going to be, we have n different than n times 1. Interesting. It's like doubling it. So if it's a 3, it's going to be what? 1 times 3 plus 2 times 2 plus 3 times 1. If it's 4, it's 1 times 4 plus 2 times 3 plus 3 times 2 plus 4 times 1, right? That's that. Okay. We can compute it. We can. Sure, that we can make the computation. O(n), right? So if we go A, B, B, C, A, we're going to split and say into AB and then BCA. And AB has, 1 times 2 plus 2 times 1. It's 4. BCA is 1 times 3 plus 2 times 2. That's 7. So that's 10. So we have that. And then crossing. Crossing. Interesting idea. Crossing. Well, hold on. The idea of crossing. When you cross, the number of uniques changes. You have to consider all the crossing. So I'm going to start from BB, right? And then go once, and then go to the right. That's too complicated. Let me think again. I like this crossing idea, but how do we handle the crossing? It kind of have a divide and conquer kind of a vibe to it. But how do we handle the crossing? All I need to know is, well, how many do we have for the crossing? Just have to take the middle two. We get one, and for each one we get here, we can get all these. For each one we can get all of these. And we just need to count the number of uniques. Okay, remember, we want to count the number of uniques. All right, number of unique for all the substrings. So let's say A, B, B, C, A. Okay, so these are all ones. Okay, now we have crossing. And then we can, oh, actually we cannot. Well, let's say we know. We actually don't know, because it has to be at each step. But hold a second. If I know, right? If I already know, I have a left substring and a right substring, right? And a crossing means we must take this on the left and must take one on the right. Otherwise, then it's not a crossing substring. Right? So we have these. So what I want to know is, no, it doesn't work. because we go once, and then this one can go this all the way, and you know every single one of them. Total number of distinct, right, for all substring. Let's say if I know that, and now I'm adding one more. Can I know everything that's ending on that? Let's think about it this way, yeah. So we have a substring, right? We have a string. And let's say we know everything. I don't care what everything is. Now I add a new one. The result of adding a new one is we can add new substrings, and they all end in this new one, right? Okay, so if they all end in this new one, I can go back to all the substrings in the past ending in here. But all the substring ending in the one right in front of me, because only they can get extended, right? Everything in the previous don't get extended, so they get extended. So from this one, let's say I have a list of all the uniques, right? All the uniques. And then I say if I am the same as the one in front of me, right? If my current position is the same as this position in front of me, then we will use the exact same thing. It does not change. What do you mean it does not change? We'll add one because these two are the same, so that substring has a P of 1, and all the other substrings has the exact same substring as the one in front of me, so it's just the same. Okay, so that's that. What if I am not the same as the one in front of me, to my left? So if I am not the same, say I'm the A, but the one in front of me is a B, right? No, I'm not the same. And then I will add, and of course, I myself, right? And then I add AB, that's another one. And then the other add is something I already done before, right? And that depends on if that position is an A, right? If any of the position in front has me, like if A is unique, A has never appeared before, okay? If A has never appeared before, yeah, let's say we have a list, okay? Let's say we have a list of I don't know of scores, okay? So we have some values, S1, S2, SI, whatever, okay? Now A comes in, all right? And what I say is I will need to find the index of the one that's the same, okay? The closest one to me. If I can find that, right, that means from that one up to me, they're all unique, right? And all I need to do is to add to it, right? Add to it. So, in my case, I will be, adding to whatever that is. But does that mean I have to keep track of all the values? Well, it's 10 to the 5th. So I will append a 1, and everything in front up to this point will be plus 1, plus 1, plus 1, plus 1, plus 1. So they're all plus 1. And everything behind, because I am already appearing that. So that substring will have the same. So in that case, I think I have a solution. Because we only have 26 letters, right? They're all lowercase letters. So they're bound to be repeats, right? They're bound to be repeats. So the number of times I have to go upgrade the entire thing is not that much. All right, let's see if this one works. I'm pretty sure I made some mistake. I forgot the PY. All right. If this one doesn't work, I don't know what to do. But anyway, so we're gonna have a DP. All right. So DP is this, and we also need all the so we have a DP. I have appeals. Okay, appeals is the score, right? And it will have to have the indices, right? Equals. It's gonna be this. Actually, it's not gonna be this. We're gonna say from the collections. We're gonna use default dict. Okay, so we're gonna say default dict a list. Okay, so now and we need from bisect import bisect light. Doesn't matter which one I use. Okay, so I'm gonna go for a letter in numerate s. Okay. Now, here's the deal. Indices append at the end. So before the indices append. So what I want to do is we want to bisect. Okay, we want to bisect. Oh, of course. Here's what we say: if, right, letter is not in indices, then indices. I can just say indices letter dot append I. Okay, so we put I into it, and then we want to say we can binary search it, right? Every time we binary search it, we will find. Yeah, we do that, and then we binary search it, and with binary search, what do we want to find? What do we want to search for? Right? We put my. Yeah, what do we want to search for? That was not binary search. We don't need the binary search. All I need is the latest, right? The latest occurrence of this letter. That's all I need. That is all I need. And then we just update this whole thing. Okay, hold on. Indices is not going to be this. It's just going to be this, right? So what we do is we say, pre-I, okay, equals indices dot get letter I. If it doesn't exist, I'll get a current one out, right? So that's the pre-I. And then my job, so appeals dot append 1. That's the appealing, because I add my current one, which is a single the single value substring. We always add one, and then I have the pre-I. Pre-I is the previous appearance of my current one, and then in between, they are no occurrence of me, so they are unique. So I'm just gonna come in and add to every single one plus one, right? And after that, beyond pre-I, right? From pre-I going back, that's not gonna make any difference, right? It's not gonna make any difference. So all this, right? All this I don't even need to keep track. I think I just need a result. It's just like from this to this, everybody has to plus one. So we just plus that much in total, right? We plus that much in total, but we need to add that, the remaining. So that's the thing. I see what you're saying. I see what you're saying. I feel like we're almost there. We're almost there. Yeah, it's the previous one. We have to add the entire thing, right? Because this to this, because this to this, this to this, this to this is the same. But this to this is the same as this to this, right? So at this position, it's just going to be a repeat. So basically, hold on. What are we saying? So, well, that's unique. So we say this is the same score as whatever I have in the past, but we just add one to it because I have one more uniqueness, right? So if I have the total score of the previous, and we're just going to add this much, right? I will add this amount, because that's the amount that's on top of the original amount. So which means, in this case, we have a res, and every time res plus equal 1, because that's we add a new one, and then, right? Oh, we don't add one yet. We need the previous one. So it's going to be the previous one plus the pre-I, right? And so pre-I equals this. And you say res and the plus equal to I minus pre-I plus 1. And then indices, letter, we update to I. Appearance. So because we're just like between appearance, every single substring is the original value plus 1. So we just need to plus that much, right? And then the total value is the original plus this. And then we return res. All right. Let's see. We have A, B, B, C, A. That is 28. This is cold. It's 20. Oh, I only have two test cases. Ay, no me gusta. But that's okay. PO sum S. Oh, pretty badly. Did I not consider some stuff? Wait, hold on. It's not rest. It's rest plus. That's the same thing? Two times rest. What you doing, man? No, seriously, I think it is two times rest, right? Because we have this to this, right? That's the original score. We have a score. From this, like all the all the scores. So we need to have a rest. Hold on. We need to have a rest. And we need to have another thing. Current. Okay. So current, right, shall be plus equal to I minus pre-I plus 1. And the rest plus equal to current. You're just playing around. I'm close. I feel I'm very close. I don't know why it's just not right. Let me think again. What is current? Current is starting from, it's actually not current, it should be previous. But anyway, current is starting from a certain position, right? And then the total score, total appeal, with all the substring ending at me, okay? Total substring ending at me. Okay, so now I have that value. Now I go to the next one, right? I go to the next one. And then we look for the previous index, okay? We look for the previous index, right? And then in between is all new, right? So I say what I can get is previous. So we say the current minus the previous. Because everything in between can get a boost. We'll have a one boost. And then beyond, we don't have a boost anymore. Right? So what I say is the original score appeal, this plus this plus this plus this plus this, right? Now become this plus 1, this plus 1, this plus 1, this plus 1, right? This plus 1, this plus 1, all the way to this. So it's going to be from I, actually yes, I minus 1, all the way to pre-I. Okay? Okay, so this amount plus 1. That is the amount we can add. The uniqueness. Actually, I don't even think we should add 1, so it's actually going to get even smaller. What? Alright. That's not right. That's not right at all. Okay, calm down, calm down. I feel like we're very close. I'm not giving up. I'm not giving up at this moment. So A is score 1. B, right? We look at parenthesis A, so we're just gonna add a little bit more. Right, so we have if it doesn't exist. Oh, if it doesn't exist, not I, it shall be -1. Right, it's the -1. I don't know why I say I. If it doesn't exist, we just go all the way back to the front. That is all the way back to the front. But can I just... No, it has to be a current. That we do have use a current to keep going and cannot do the total thing. Then, yeah, that's it. This is the solution. This is the solution. I mean, if you don't feel comfortable, you can always just get a bit bash, right? You can always get a bash. And then try it. And it's correct. Wow, we just solved a hard problem. Yep, that's the thing. I'm very impressed with myself. I did not expect it, but it is an easy problem. It's a one of the easier ones. This is one of the easier hard problems. So the idea is DP. It's always going to be DP, right? So here is the thought process. Say we have the total appeals, right, of all the substrings ending at si-1. Okay. Now we are looking at si. If we count from si-1 back, right? Count back until the first letter that is the same as si. We know that let's say that letter happens at sj. Then we know for sure from sj plus 1 to si-1 si, there is no si. Therefore, all the substring ending at si that starts from within sj plus 1, that it starts from sj plus 1 to si-1 has one more appeal than all the substrings that starts from within sj plus 1 and ends at si-1. All the substring that starts before sj plus 1 has this and at si has the same appeal as the substrings that starts before is j plus 1 and ends at si minus 1 due to si and sj being the same. Therefore, if we have the total appeal of all the substrings ending at si minus 1, the total appeal of all the substrings ending at si is let's call it current. The total ending at this is current plus I minus j. Thus, we have our dp condition, current plus equal to I minus j. I don't like that. Now the question is how to find j efficiently. We can use a dictionary or an array because there are only 26 letters to record the most recent appearance index, most recent index where a letter appears. If a letter has never appeared before, we set the index to -1. When, yeah, simple solution. I think everything is pretty straightforward. DP, easy and concise. Is default dict. I think this is my solution. N minus I. I don't know what this is. I will stick to mine because it makes sense to me, but overall it's pretty much the same. Okay, I'm surprised I got this one done.